Hi folks, welcome to Java Technophile. In this video, I will explain one of the most powerful concept software developer and software engineer, that is nothing but solid principle and their use cases. We will discuss who should learn the solid principle as well as when and where should we apply them, and focusing on the real world use cases of the solid principle. And the solid principle are essential for anyone who involved in the software development field, particularly software developer, software architect, project manager, quality assurance engineer, students, and new developer. Why a software developer need to learn solid principle? Because a software developer need to write cleaner code and maintainable code. For this, a solid principle is necessary. Why a software architect should know the solid principle? To understanding this principle aids in design the robust system and scalable system. Why a project manager should know the solid principle? Project manager should know because it can improve team communication and project outcomes, and delivery of the project will be faster. Quality assurance engineer must to know solid principle because it can enhance the testing strategy, and a student and a new developer should also know the solid principle because learning this fundamental principle early can shape good coding habits for a new developer or students. One important note is, if you are one of among them, don't dare to skip this video because this is most asked interview question and used in daily software development. Without this, your interview and workday won't be completed. Mark my word, guys. And overall, anyone involved in the software development lifecycle can benefit from the understanding of solid principle. Whether you are a beginner looking into improve your design pattern or an experienced developer aim to refine your architectural skill, this video is for you only. Don't miss, guys, and watch till end. Further, we are going to discussing when to use the solid principle with real-time use cases, and we will cover how to apply this principle during the different stages of development. Let's discuss when to use this solid principle. It mostly required during design phase to build scalable and maintainable architecture, and when a developer refactoring the code to improve existing code and make it more modular. This is required. And whenever a developer configuring a new project to establish solid fundamental from the start, and when adding new feature to keep the code flexible and adaptable. By the end, you will exactly when and where implement solid principle in your own project. Let's deep dive into the solid principles, where we should apply the solid principle and why they are essential in the modern software development. In object oriented programming, solid principle form the foundation for design, cleaning, and maintainable code. And in team environment, they help enhance the collaboration and team maintain consistency across the code base. And when you have a complex system or a enterprise application or a project, solid principle are key to manage the dependency and reducing coupling between the components like classes, methods, all those. And finally, in testing of the application, this principle make it easier to write testable, mockable code, improve overall quality. Basically, we can say solid principle is nothing but applying the object-oriented principle efficiently at the time of application development. Why you use the solid principle? Because to achieve the huge conflict between the component like classes, methods, and interfaces, all those, which helps improve code maintainability and reusability and during the software application development. The solid principle is an acronym for five key design principles. One is S for stands for single responsibility principle, O stands for open close principle, L stands for Liskov substitutions principle, I stands for interface segregation principle, and D stands for dependency inversion principle. Let's deep dive into first acronym of solid principle, that is nothing but single responsibility principle. Single responsibility principle says every software module should have only one reason to change. It means a class should contain only one functionality code, or a class should have only one responsibility, not multiple responsibilities. It doesn't mean For every functionality, separate class will be. If it is, then it will leads to the readability and maintainability issue of the code. Instead, a class can have multiple methods as long as they all serve the same purpose. You can declare a multiple method in a single class having same functionality. So a class can contain multiple method also. All the method responsibility must be one. In case if you give multiple method to a single class with a different functionality, then you are giving unnecessary stress to a class as well as code becomes clumsy, and any further requirement changes can lead to more complexity and making it longer to update or deliver the software application, because a new developer or other developer when will work in this class, this time it will get confusion or it will get a long time to understand the functionality of this class. As you can see on my screen, there are two examples. One showing the SRP violation and other demonstrating SRP implementation. Let's first understand how SRP violation leads to clumsy and inefficient outcomes or delivery of the project. Imagine you are a developer with multiple responsibilities, like you have to develop front-end code and you have to develop back-end code, as well as you have to handle the deployment part as well as the operation part, and in case certain time required, then you have to manage the project during the development phase. If one developer tries to handle all these tasks, they won't be able to deliver any of them on time, nor will the quality of the work will be the best. These are the problem we'll face if we implement multiple functionalities in a single class, or if we assign multiple tasks to a single developer. Let's deep dive into if we implement SRP principle or solid responsibility principle implementation, and if we divide the tasks based on the development criteria. Whenever we are applying the single responsibility principle, each developer or engineer focus on their specific tasks, which results in timely deliver and higher quality product. Then let's understand the code of solid responsibility principle and its implementation. In this example of the SRP violation, there is a class student registration is overloaded with multiple responsibilities like registering the student, get the registered student details and sending the OTP during the registration, and get the attendance details of the students. Here having multiple functionality in a single class. In case any changes in the OTP sending logic, we will make the class cluttered and hard to read. And this can lead to confusion of the other developer working on the student registration class. Or if you changes logic in the attendance and details based on the academic rules, it will lead to confusion to new developer which part should be depend on which part. This ultimately delaying the delivery of the application. By violating single responsibility principle, we are creating a class that difficult to maintain the code and understand the code for a other developer. Let's talk about the implementation part of the SRP principle. If we follow the single responsibility principle, what are the benefits? Let's discuss. And how we achieve? Let's discuss. For each independent functionality, we have to create separate classes. For example, one student registration, another is OTP sending and resending purpose, another class, and another different class for the managing student attendance details. Like we have to create three class for student registration, one class for OTP notification, one class for student attendance detail, one class. Every class contains their functionality or methods based on their requirement. This results in clean and organized code, enhancing both the readability and maintainability of the code. It enables the developer for parallel development purpose and speeding up the development process and ensuring faster delivery. By following single responsibility principle, not only improves the code quality but also boost overall productivity in software development. Let's summarize all the discussed points and what are the benefits of single responsibility principle. We are getting the benefits like maintainability of the code, reusability of the code, and testability of the code. Maintainability of the code means each class has a single responsibility so that making it easier to change one aspect without affecting other responsibilities. And let's come to the reusability part. Each classes can have reused independently in different part of the application because their functionality based on the functionality we have designed the class. Let's get to understand the testability. Testability nothing but each class contain isolation logic based on their functionality. So it is simplifying the unit testing process. By following the single responsibility principle, the code is cleaner, easier to maintain, and more modular. This is all about the single responsibility principle. Now let's deep dive into the second acronym of the solid principle, that is nothing but open closed principle. Open closed principle states that the software entity such as classes, modules and functions should be open for extension but closed for modification. This principle encourages a design where new functionality can be added without changing the existing code, and this minimizes the risk of introducing bugs. By following the open close principle, you ensure that your code base remains flexible and adaptable while keeping it stable and secure. Let's explore how it works in practical or practice. As you see on my screen, a dog doesn't want to change his behavior for new things adaptability. Dog plans for a new children, that is for a new changes adaptability. This image appears to depict a humorous presentation for the open close principle using cartoon character. Here how it connects to the open close principle concept. The first character says, I don't want to change. This represents the idea that existing code should be closed for modification. Once modular class is written, you should not alter its internal logic. If you change its internal logic, it might lead to the bug. And the second character responds like, but I make a children. This refers to a new functionality should be added through extension instead of modifying the existing class. New features are introduced by creating subclass or extension which inherit from the base class. This is one of the Oops principle of the inheritance. And the third character says, I am not sure I understand. This means this could reflect confusion about the principle itself. Commons for developer to initially struggle with the idea of not modifying the existing code, but instead of extending its new modular way or new functionality. Then let's explain easily by code, and let's understand OCP principle by code example. Let's have a e-commerce application initially integrates payment processing for the credit card only. We have a payment processor class that handles credit card payment only. As our e-commerce platform grows, we want to add new payment system or other payment method like debit card or UPI. To adhere the open close principle, we should extend our system without modifying the existing code. Instead of adding new methods directly to the payment processor class, we will create a separate class for each payment type that extends a common interface. This way, we can add a new payment is method easily in the future while keeping our original payment processor intact. As you see on my screen, there is a class payment processor. There is only do credit card payment method is there. After business is increasing, there debit card payment and UPI payment added. This leads to the OCP principle violation. As OCP principle says, it open for extension, closed for modification. So we have to provide abstraction, and we have to declare a payment processor interface, and for every and each payment we have to implement the payment processor method, and you have to write the logic so that we can achieve the open close principle. or or in case in future another payment method comes, This way, we can add new payment method easily in the future while keeping our original payment processor interface intactly. Let's explore some common use cases for the open close principle where software is open for extension and but closed for modification. Let's say example is a plugin system is there. Use cases like building a pluggable architecture for software. Example, a graphics editor supports multiple image formats. New formats like PNG can be added as a plugins without changing the core image handling code. This is the one of the example of the OCP principle, and another example is like the payment processing logic. As we had discussed, we can integrate a new payment platform without changing the existing code like PayPal, Stripe by defining common interface. Let's discuss when should we use the OCP principle in our project, or in which scenario we have to use. When a project having frequent changes expected in the development phase, and if suppose a large code base or a bigger project or bigger application have that open close principle promotes modular design, make it easier to manage and reducing the risk of breaking existing functionality. And there is another scenario for code reusability purpose. OCP principle helps a lot to create generic interface that can be implemented in a various ways, enabling code reuse across different part of the application. Let's summarize the open close principle. Using the open close principle, ensure our code remains flexible, adaptable, and easier to maintain as our project grows. The main aims to extend a class behavior without changing the existing behavior of a class. This is to avoid causing bugs and whenever the class being is used. Let's deep dive into third acronym of the solid principle, that is Liskov substitution principle. Liskov substitution principle states that the object of a superclass should be able to replace with the object of a subclass without affecting the correctness of the program. And this principle is named by the Barbara Liskova, and who first formulated it in the 1987 by a paper. Let's understand this Liskov substitution principle in a layman words. Ob- Object of a superclass should be able to replace with object of a subclass without affecting the program or without disturbing the existing program. Or object of a subclass should be able to access all the method of and properties of a superclass. As you see on my screen, the image provides an example of the list of substitution principle using different version of Visual Studio. Visual Studio Code 2005 versus Visual Studio Code 2010 to explain the backward compatibility. Visual Studio Code examples in the image. The Visual Studio Code 2005 represents the base class and the Visual Studio Code 2010 represents the derived class. The statement Visual Studio Code 2005 can be substituted by Visual Studio Code 2010. It still works. It illustrates that you can use newer version in place of older version and the system will function correctly and maintaining backward compatibility. As we know, there is a multiple inheritance are there, and as you've seen on my screen, there is a class A and there is a class B. Class A is superclass and class B is derived class, where class B extending the functionality of a class A. According to the Liskov substitution principle, we should be able to replace an object of class A with an object of class B without breaking the program. As you see on my screen, I have written clearly. These are the example I have discussed. Let's discuss another example. There is a class, a car class, contains a function do start engine that is designed to start the car's engine. And there are derived classes like Honda car and Maruti car. Both Honda car and Maruti car extend the car classes and inheriting the do start engine method, but they each have their own specific logic. According to the Liskov substitution principle, you should able to replace an instance of a car class with an instance of Honda car or Maruti car without affecting the behavior of the program. In this driver class, the object of Honda car and Maruti car can be replaced the car class type, and their method can be invoked without breaking the system. I explained clearly. Kindly practice this program, and what are the benefits we will get if we implement the Liskov substitution search principle. If you implement the LSP, you will get the code flexibility that allows more flexible and interchangeable code components and improve the maintainability of the code that ensure subclasses can be used without fear of breaking the existing functionality. And this by implementing Liskov substitution principle, it enhances the readability of the code, keeps the behavior of the class intuitive, and make the code easier to understand. By adhering to the list of substitution principle, you ensure that your class hierarchy are robust and maintainable. That is the efficient way of implementation of inheritance. Let's discuss some of the use cases where should we use the list of substitution principle. When designing class in hierarchy ways, uh, we can ensure that subclasses can substitute their parent classes without causing issue. And during code refactoring also, we can apply the LSP principle. If you are refactoring the existing code, check if the subclasses adhere to a list of substitution principle and refactor as necessary to avoid violation that could lead to runtime error. And we can also use whenever we are implementing interface and writing the polymorphic code. By applying Liskov substitution principle in this situation, you will create a more robust and maintainable code base, making it easier to work with and extended over the time. Let's discuss interface segregation principle. As I already explained, the single responsibility principle, open close principle, and the Liskov substitution principle in the previous slides. So let's focus on the interface segregation principle. What interface segregation principle states that clients should not be forced to depend on the interface that they do not use, or classes should not be forced to implement method they do not use or they do not want to use. Instead of having a large interface in all-in-one interface, it's better to have a smaller, focused, and very simplified way. Interface segregation simply means that we should break larger interface into smaller one. If we understand in the layman example, interface segregation principle says we have to divide the interfaces functionality into smaller one by their sub functionalities. As you see on my screen, there are two images. In interface segregation principle states that client or classes or objects should not be forced to depend on the interface they do not want to use. In simple term, a class should not implement methods it does not need. As you see on my screen, on the left side image, that is a violation of the interface segregation principle. In this example, there is a large interface I worker containing multiple methods including like tea break, oil check. This is the issue that both human worker and robots are required to implement the same interface. However, robots do not need tea break and lunch, and humans do not need battery charge and oil check. This leads Violation of interface segregation principle because both classes are forced to be depend on method they do not want to use. As you see on right side image, this is the implementation of interface segregation principle, where clients should not be forced to depend upon interfaces that they do not use. In this site, the interfaces is broken down into smaller one and more focused interface. And there are categorized three interfaces: I worker interfaces for general work operation, I human operation for methods specific to human workers like tea break and lunch, and I robot interfaces for method specific to the robot like battery charge and oil checks. This segregation allows each class to only implement the method it actually needs and adhering to the interface segregation principle. Let's deep dive into the code part of an example of implementing an interface in Java for handling bank payments. So here are the code example of interface segregation principle. So here we have a basic example of an interface called SBI payment and a class called SBI bank payment that implements the SBI payment interface class. As we move ahead in the time, the more features comes in, and there is a need to add loan service as well. And in this picture, as I written, there is a interface SBI payment contains the initiate of the payment and the status of the transaction and the get the payment details. And the in the SBI bank payment class implements SBI payment and override all these three methods. As the business grows, when the new functionality or new module added like loan payment service, this service also one kind of payment, and but has a more feature operation. To develop this new feature, we will have to add new methods to the payment interface. If you add in the same SBI payment method, then it leads to the interface segregation principle, and code becomes clumsy and difficult to understand the logic because it mix up the code. As you see on my screen, there is a loan payment class that implements the SBI payment interface that unnecessarily adds to adds other methods that required for payment as well. For loan, we have a two method: initiate loan settlement method and initiate repayment method. This is two method only required for loan repayment purpose, but unnecessarily initiate payment, status of the payment, and get payment details method are added. Then let's discuss the if we follow the interface segregation principle, how the code becomes easier to maintain. So we have to divide the interface functionality based on their business needs. Like for payment purpose, separate interface, SPI payment, as I given on the screen. And there is for loan purpose, there is separate interface, this way SBI loan. We are taking two separate interfaces and based on their requirement, we have segregated the functionality of these interfaces, and based on the requirement we have to implement the SBI payment for SBI bank interface, and for a loan purpose we have to implement the loan interface, and it leads to the clean code. We should segregate the payment interface like SBI payment and SBI loan payment. This way, SBI payment class is not forced to implement loan related functionality, and the SBI loan payment class does not force to implement other payment related functionality. This is a perfect real time example of the interface segregation principle. And let's understand the some use cases of the interface segregation principle. When we are using the interface segregation principle, it reduces the complexity of the code because we are separately write the logic for functionality and for each class. And another use case, like in the microservice architecture, each services can expose only the necessary API for its specific functionality and ensuring clients only depend on what they are required. Let's understand another example as well. Evolving the requirements, or when the requirement changes, smaller interfaces allow to extend the functionality without affecting the existing implementation, making your code base more adaptable and reusable. And another one is legacy code integration. In this scenario where we are integrating with legacy system, creating a small interface can help encapsulate the legacy behavior without forcing new class to implement all the method. By applying the interface segregation principle in these use cases, we can create more modular, maintainable, and flexible code base. By following interface aggregation principle, you can create a code base that is more organized, adaptable, and easier to work with. That leads to higher quality software delivery. Then let's deep dive into or discuss last acronym of the solid principle, that is dependency inversion principle. Inversion principle says high level modules should not be depends on low level modules, and both should depends on abstraction, and abstraction should not depends on details should depends on abstraction. As you see on my screen, there are the controller layer, service layer, and DAO layer, and integration layer. Actually, whenever we are a developing project, we are following the entire architecture, which consists of layers such as the controller layer, service layer, and integration layer, and etc. And in this picture, and there is three layer. There is controller layer, service layer, DAO layer, and database is there, and front end service as well there. And in this picture, the controller layer depends on the service layer. In the project also same. The service layer depends on the DAO layer, and the DAO layer depends on the databases. In this picture, the target layer is considered as a higher model, and the dependent layer is considered as a lower model. In the entire architecture, controller layer depends on the service layer. The controller layer is the target layer, and the service layer is the dependent layer. And the controller is the high level model. The service is the low level model. And the service layer is depends on DAO layer, and here the service for this purpose service layer is a high level module, and DAO layer is a low level module. If high level modules and depends on the low level modules or are tightly coupled with this module, then it leads to the code fragmentation, because code will easily breakable. If any changes done in the lower level model, the higher level model code will be break. The main goal of the dependency inversion principle is that the controller should not be tightly coupled with the service layer, and the service layer should not be tightly coupled with the DAO layer. This means we should avoid direct object creation, and we have to provide abstraction for the object creation process, so that there is you have to achieve loosely coupling between the components or layers. As you see on my screen, there is a businessman calling his driver to come for the pickup, but the driver is saying I am busy with that time. Here, the higher module should not be dependent on the lower module. Here, lower module is the driver, and higher module is the businessman. Due to its dependency, the businessman get disturbed, and on-time delivery is not possible for the businessman. Like in this, we have to achieve in the code as well by implementing the dependency inversion principle, and and by providing the abstraction. If you know how it works, it is a burden for the developer, where we should not know. This means whenever we are designing the software, we should reduce the title coupling between the high level business logic and low level utility code. like database operation and user inputs. And by depending on the abstraction like interfaces and abstract classes, systems are more flexible and maintainable and resilient to change. As you see on my screen, there is a dependency inversion principle violation example. For every project, there is a backend development as well as front-end development. For example, I have taken a class, a backend developer and a front-end developer. Here we are tight in the project cases. We are tightly coupled with the front-end developer and the backend developer. In case any changes in the backend developer or front-end developer, the project will be collapse because this is completely tight coupling with the backend developer as well as front-end developer. And here high level classes depends on the low level concrete classes like backend developer and front end developer. In this design, if the backend developer or front end technology changes, like front end technology moves to from JavaScript to TypeScript, the project class will need to be updated, which tightly coupled to its details of this implementation. This violates the dependency inversion principle because the project class should depends on abstraction, that is an interface, rather than specific implementation. So let's discuss how we achieve it and how we apply the abstraction to achieve the dependency inversion principle or we apply the dependency inversion principle. By following the dependency inversion principle, you would introduce an abstraction or like an interface that both a backend developer and front-end developer have to implement. Clearly in the code, I have written a interface developer and that backend developer and front-end developer implements that uh, and developer interface. So the project class only depends on the abstraction, not the concrete class itself. The project class depends on the delivery or developer abstraction. Any changes to the underlying implementation, like switching to new technology like Python or TypeScript, would not require change in the project class as long as the new classes implement and deliver. And let's get understand the benefits of dependency in inversion principle. If we follow the dependency inversion principle, we will completely achieve the loose coupling and abstraction. And this abstraction achieves on reduce the burden on the developer. And code can be easily extend and increase the testability. Like project services depends on the interface. You can easily mock the backend developer and front end developer for unit testing and making it easier to test the business logic in isolation. Let's summarize the dependency inversion principle and use cases. Dependency inversion principle is useful if we want to decouple high logic business logic from the specific implementation, and it allows system to be more maintainable, flexible, and easier to test by promoting the use of interface or abstract classes. This is a mostly asked interview question. Kindly watch many times up to the understandable to you and practice the code accordingly, because without this question there is no interview. The experienced developer as well as fresher, and in your day-to-day life of the software development, you have to use this principle. Thanks for watching my videos. If you like my videos, kindly subscribe my channel and watch and subscribe for more content.